I'm Braden Barbary, and this is my Lab 5, which is about work done by contact force. So, my lab was about the energy principle, which is objects have a constant energy unless acted on by force outside of the system. That statement is the same as the equation work equals change in energy. For my lab, Tracker and GlowScript were both used, and in it, the balled up paper and the Earth's gravity were the system, and the ground was the surroundings. The main loss of energy, and in the end, I found that the main loss of energy was due to contact with the ground. So the main concepts of my lab were energy principle, which is the change in potential energy of gravity equals mass times Earth's gravity constant times the change in height, or y. And then the change in kinetic energy is 1/2 mass times velocity final squared minus velocity initial squared. And then also Newton's second law, which is that the velocity final equals velocity initial plus force, net force over mass times delta t, and the position update, which is position final equals position initial plus velocity final, which is velocity final because it's a non-constant force times delta t. So for the testing, Tracker was used to observe the object's position, and individual points were placed at the center of the object for every frame to track the movement. The object that was tracked is in this slide right here, and as you can see, it's thrown up into the air, and its bouncing is one of the most important things I looked at for this lab. So for the coding, the tracked video was used as a goal for the data that the code gives me. By creating a GlowScript code, I was able to see an estimation of what the energy change was when the paper ball hit the table. So in my code, there are some more important parts. Here, I have the force, which is gravity, and then the mass, which was just the average mass of a piece of notebook paper. This is my initial velocity, which I found from looking at the first 2 points in my tracker video and averaging those velocities to find what the initial one was. And the ball's radius, which was just an estimation of what it should be. And this restitution is how much energy is lost when the ball hits the ground. I just played around with different values until I found one that looked appropriate as to how the tracker video was. And then here's the formulas for kinetic and potential energy, which I went through earlier. Some more important parts of the code. This is where the energies and velocity and position are updating, and it's still the same formula as before, just in a while loop. And then here is the video of my tracker data, my tracker code. Sorry, my GlowScript code. And as you can see, it went up, it goes up and then bounces off the ground, which I thought was very similar to the tracker video. So for the calculations in this lab, with the formula work equals change in energy, I can look at the point of contact with the ground. Then I could go look at the difference in energy to find the work. I found that it bounces at 0.868 seconds. And before contact, it has the kinetic energy of 0.0269 and the potential energy of that number. And those added together gives this number here. And then after contact, I did the exact same thing with the kinetic and potential energy to find this value. And when I subtract the final minus initial, I find that the work done by the ground or table is negative 0.01832 joules. Now, what if all the forces were included? The value I calculated is a slight overestimate due to the work other forces are doing on the paper ball. The biggest force I left out is the drag force. This force cause the kinetic energy to be lower, which would lead to a lower change in energy. Finally, as a conclusion, the contact force greatly lowered the magnitude of non-rest energy the paper ball had. Due to how large the change in energy was, it can be assumed that the contact force with the ground will cause the largest change in energy for any thrown object.